So it's finally time to test Clicky McClickety Mark 1. First off, let's listen to the ambient room sound. This is the sound that you're listening and trying to focus on the mix of the synths at the same time as trying to use the noisiest sequencer ever conceived. Nothing says optimum studio setup than a really noisy sequencer, after all. And in the end of the day, when you listen to the direct recording and you've isolated just the synthesizers and you're not actually listening to the relays and stuff, well, it's pretty much the same as any old 8-step sequencer, so it's fine, it's fine. But regardless, even if you have headphones on, you can still hear this in the background, and it sort of does affect the transients and the way you're trying to treat the synthesizer. In the end of the day, it's a bit of fun. We're not trying to send anybody to the moon with this thing. Maybe we should. First off, this thing is actually wired up slightly different to a normal sort of 8-step sequencer. So these knobs right here have potentiometers around the back of them. These are variable resistors, and usually in sequencers like this, you have one side of the knob that's actually wired to something like ground, so it goes to 0, so it sends no pulse in, and then this side is actually wired to something like a counter chip or something. This actually tells the potentiometer when to turn on, so like they're always, this is multiple ones and they're all going to ground, and then the middle leg of the potentiometer, they all actually connect together somewhat, and this goes to the output. With this relay sequencer, however, the potentiometers are wired slightly differently. These are the potentiometers, this is the knobs that we're twisting. This is leg 1 of the potentiometer, leg 2, which is the middle leg, and leg 3. These are all connected together, and then these are all connected together, and then these go off to the relays and turn on to the outputs. So you can actually select the knob anywhere between this side, and it sort of acts like a crossfader. But the thing is, with this sequencer, well, these aren't fixed voltages. You can wire whatever you want into them. So here's the output. This is the sequencer output. That's the middle leg of the potentiometer, and then the left and the right of the potentiometer, you can wire whatever you want into it. So now we're gonna wire this up to act like a traditional sequencer. What we're gonna do is we're gonna wire 2 voltages into the top and the bottom of the potentiometers, and we're going to use this module. It's an offset module, and it's able to send out 2 separate voltages. What we're going to do is we're going to send one side of the potentiometer to 0 volts and the other side of the potentiometer to plus 5 volts or something like that. Then it's going to act like a normal sequencer. But then what if instead of sending the bottom of the potentiometer to 0 volts, we actually send in a negative voltage? So that means that, like, for instance, this side is minus 5 volts and this side is plus 5 volts. Well, it acts like a normal sequencer, and still you'd start adding more steps into there. So what if we send in more steps, so more relays are on? That means if the knob is selecting a positive voltage, then it's adding the voltage to the output. But if that knob is selecting a minus voltage, well, you're subtracting from the output. So if there are 2 knobs selected, one says plus 3 volts and the other one says minus 3 volts, well, you actually get 0 volts out of the sequencer. And you can keep on adding more steps and making this variation more and more. It just means it makes it a little bit different. Next, due to popular demand, I put a contact microphone on the back of it and I plugged it in. To be honest, I didn't make much effort because I aren't really planning on using this in the museum setup because it's already loud as heck as it is. So this is going to be on the wall. I'm just going to take this off in the end. Needless to say, you can add more microphones into here, like one here and one there, to get a sort of stereo view of it. But to be honest, my studio speakers are actually stacked on top of each other, so the stereo field is sort of lost on me. What I did is I plugged the contact mic through the 4710 safety valve, and this boosted the contact mic's output to modular volumes so you can actually mix it in with the music. And that means you can send the actual relay sounds into delays and this, that, and the other. And then what happens when we flick one of these switches to the stop command? That means when it gets up to that step, it actually stops. The cool thing about this is it really makes some varied sort of robot sounds. That's because you're adding and subtracting steps. There's different amounts of steps going on at different times and stuff. So it's going all a bit, you know. Now, like I mentioned, you can actually plug whatever you want into these sides of the potentiometers. They don't need to be fixed voltages. They can actually be whatever you want. Like I said, it can sort of act like a crossfading module. So what I did is I unplugged one side of the potentiometers and actually plugged it into an LFO. That means one side of the knob was an LFO and the other side was a melody. Now we're bouncing between a melody and an LFO. And now it's time for the fun part. Not that this wasn't fun, it's just it's going to get a little bit funner, right? The reason why I didn't put much effort into the piezo mic around the back of here, that's because I've already got a relay module inside my modular that's already got a piezo speaker inside it. It's called the Mega Duck, and I've made this relay module basically just to make hard stops on all of the audio. For instance, if you want everything to stop at the same time, then you turn this on, we're using a trigger command, and boom, everything turns off. And then when you plug the piezo microphone from that module into the safety valve, well, you know, you can hear the module in there. But what if instead of using a trigger command to trigger these relays, why don't we use an oscillator at audio level to trigger these relays? The relay is sort of acting like an electromechanical speaker in a way. It sort of sounds like stepper motor kind of music, you know, like Flopatron and all that, those printers and stuff, because it's a similar kind of premise. I'm waiting for the comments being like, oh, you're going to break all your relays. Well, funnily enough, that thing has been going for the last 2 years. I've been driving it like that for 2 years and it's still working. So yes, it may die at some point, but it hasn't died yet. The reason it has an interesting sound is because when it's being triggered at a slower rate, it's making a more definite click, and you know, the mechanics is able to move to its destination in time. So it's quite a big clunk, and as it gets higher and higher, the note actually gets softer. That's because it doesn't actually quite get to its ending point, so it doesn't quite make as many clickety-clicketies, and it makes that really recognizable electromechanical oscillation sound. And then why not? Let's see how fast we can get it to go. So this is Mark 1 of Clickety McClickety, and there is a sound pack available on my Patreon and YouTube membership of this doing its thing, like just an extended kind of bunch of audio from when I was jamming with it, so you can use it in like samplers and stuff. So go and check them out over there. But the thing is, as I sort of plan on building on this idea and sort of making it into a much more elaborate and more complex sequencer, but still based on relays. On the first relay sequencer video I did a couple of weeks ago, Ken Stone commented on it. If you're not aware, Ken Stone is a synthesizer DIYer that has been contributing to the online synthesizer community for over 2 decades. You may better know Ken's work under the name CGS. If you are into synthesizer DIY and have not yet stumbled upon CGS, potentially you've been living under a rock, I'm not sure, but the links are below if you're interested. But Ken mentions the fact that he had a crack at a relay sequencer, and it varies in design somewhat. Mine being a little bit more based on the flip-flop kind of thing that Moog have done. His design is more based around the way the surge sequencers work. So I decided to breadboard the CGS relay sequencer to see what it was all about, and yeah, basically just weigh up the pros and cons between both of them. And I'll be doing a video on this next because there's lots to talk about, because they're similar in some ways and very, very different in other ways. But amazingly enough, this one can act like a keyboard sequencer, which is always good. I built this over a couple of builders live streams last week, and I've got to be honest, I did struggle a little bit, but now it's working, and in the next video we can compare notes. So for the video today, that's it. All of the links that I've mentioned are below. There's a bunch of extra content around these, including builders live streams and stuff like that, including a brand new live stream modular megamix, and that's all available over on Patreon and YouTube membership. So if you want to support these kind of videos and the opening of the museum, which I hopefully, fingers crossed if nothing goes wrong, will be in July, yeah, this BeatStep Pro sequencer, I mean, it's going to require a lot of relays, and relays aren't cheap, it's fine. I'm going to be building it anyway, but if you want to soften the blow somewhat, because these, yeah, it's going to be pretty intensive. Anyway, until next time, I've been Luke Mum No Computer. If you like what you see, don't forget to subscribe, and don't be scared to try it. Woo!